Okay, in this video we'll show you how we can machine the part that you see on the screen here. Okay, so the first thing to do would be to use a roughing strategy. So we're going to use the advanced machining, so we go into the milling tab, advanced machining, and we can set the speeds and feeds to whatever we want them to be, and we'll select a tool. So we'll use a 10mm end mill, and then under surface paths we choose triangle mesh, and then the type of cutting we're going to do is roughing. So what it needs is it needs to know which of the machining surfaces. Now in this context it's not an individual surface, it's the model itself. So if we select that, then we can select a machining surface. So we highlight it and press the enter key. And now, because this is roughing, we might want to leave a finishing allowance on here. So we do that here. The finishing allowance can either be a global, pardon me, a global amount, or it can be separate for radial and axial. So in this instance we'll have global, and we'll have 0.25 of a millimetre. The heights that we're going to use, we'll choose that we want to select it from the machining surfaces and from the stock, which I'm going to define now. So to define the stock, we go into the roughing tab, and we don't need to define a piece of geometry for the stock, because we're going to use this method here, which is to use a bounding box. So what this will do is it will look at the model and create a machining path which is bigger than it, and we can further make that different by expanding the amount here. So we're going to leave that all the defaults as they are, and then back into surface paths here we can set the constant depth step. So if we're using a 10mm tool, maybe 2.5mm, and the step over down here will be 5. Under the link we need to set up our retracts. So depending on the size of the component, this may or may not be right, so I'll set this to 50, and then because it's a fairly small component, I'll set these values down here to 5. Okay, so that's pretty much all we need to do there. So we click OK, and that creates the roughing tool path for that. Now, one thing that may or may not happen is that the depth that we've set may or may not coincide with any flat areas that are on the model. So if we want to change that, if we double click the entry here, and then under the depth step, advanced, we can say machined flatland. So what this will do is it will add in intermediate slices where it sees any flat areas. Okay, so that's created the roughing path for that. If we want to save that way, then we can do, go to File, Save As. I've already given this a name, so I'll just click on Save, and then under Milling we go to Simulate, and then here we can build the stock model from the extents. This is the XYZ extents of the component. In this case I don't need to leave any extra stock on the sides or on the top of the model. So once I've done that and created a stock model for the simulation, then we won't need to do that again. So that sets up a stock model. So this is purely for the simulation, it's not the actual cutting path. So we can run the tool around here, and then we can speed up or slow down the display here. Okay, so that's what's been machined thus far. So if we close down the simulator, we go back into the CAM system. So what we can do now is, if we wanted to, we can just switch off that toolpath. So now we can concentrate on doing the finishing here. So what I'm going to do is use a constant cusp method of machining to do the boss here first. So to do that, we need to create some sketches to limit the machining. So to do that, with the cursor in the graphics area, I right click and choose faces. So click on the face and say make a sketch from this face. So what I've now got is an entry in the objects window here, which is a sketch which is made up of the outside shape, the flat area and the bosses. So if I want to separate those sketches, with the cursor over the entry here, I right click and say split the sketch. So I've now got individual sketches. So these will be used just to limit the machining, which you'll see now. So let's go back into advanced machining, and we'll change our tool to a smaller ball nose end mill, and the surface paths this time are still based on triangle mesh, but we want constant cusp. So what this will do is it will produce a tool path based on the cusp height between the passes, so it'll use as many or as it needs to, depending on the curvature of the shape. You would use this in preference over constant Z, where you'll get a number of cuts in Z. Each one will have the same value, but it won't take into account any of the curvature. So constant cusp will introduce more cuts where it's needed. So again, we need to define the machining surfaces, or the block that's going to be machined. So we highlight that and press enter. I don't want to leave a finishing allowance or an offset on here, as this is a finishing pass. I've set the tool, I'll leave the heights as they are, but I want to limit the machining to a containment area. So I come down to area here and I switch on 2D containment, and then I click on the word here, 2D containment, and then I can select the curves I want to use. So I can either pick it from the model here, or I could pick it from the objects window here. So I want to limit the machining to this curve here, so I highlight it and press enter, and I want the contact point there to be the center of the tool. So that's going to machine that. The only thing I do need to check is the step over here. So let's have 0.25. So that creates a tool path which will finish that using the constant cusp height method. Okay, so that's machined that. So we could use that same strategy to machine these holes if we wanted to, if they're not square holes that can be drilled. In this case they're tapered. So what I'll do first is I'll just create a smaller tool to get into there. So I'll go into tool, and it'll be a ball nose end mill, and I'll set it to a diameter of 4. So when you create a new tool, it shows you a graphic on the screen there. If we look at the tools list here, we can see the tools that we've got in the library here. These tools will be saved away with the job when you save it later. Okay, so now we can produce the same tool path that we did previously, but rather than having to go through all of the operations again, what you can do is, if you highlight the previous operation in the objects window, right click and say copy, and then click on the word operations, right click and say paste into, then what that does is it creates a copy of that machining operation here. So I can go into there and just change a couple of the parameters. So the first thing I want to change is the tool. So we're going to use the 4 mil end mill, and then we also want to change the containment area. So if we click on 2D containment curves, and then we can simply pick the new curves we want from the graphic. So if we hover over that and click, now if I hold down the control key, I can then select the other curves there, and then when I'm finished I press enter. Leave that as it is. If we wanted to, we could change the step over or the cusp height here, but we'll leave those as they are, and that produces the toolpath there that you can see. Okay, so now you could use a similar technique to machine the outside shape. So what we'll need to do that is we'll need a sketch which represents this outside shape on the bottom. So if I just move the model around, right click on the face and say make a sketch, then in that window here I've got a sketch which is made up of the 4 holes plus the outer, and I want to separate those, so I right click and say split the sketch. So now what I've got there is I've got those sketches. Now I'm not going to be using the holes, it's just that one which I need, which is the outside shape. So what I'm going to do is I'm going to create another path which is similar to what we've done previously but will limit the machining to the outside edges. So let's have that one and right click and say copy, right click on operations and say paste. So I've now got another one there, so I can just go into that one and we'll just change our tool back to a small to the bigger tool, and yeah, we might want to even use a bigger tool, but we'll stick to the 6mm one. And then under surface paths, we're still using constant cusp. The machining surfaces have been set, but we want to change our 2D containment. So I'm going to choose 2D containment curves, and I'm going to choose the top curve here. So I click on that and then hold down the control key and then choose the bottom curve there, and then press enter to accept that selection. So I've done that, but now what I need to do is the trimming criteria here. I need to change it to the tool contact point so that it goes round past the shapes, and you'll see what happens in a moment. And I'll just change this back to a larger number because I don't think we need the that finer finish there. So that's now calculating the toolpath. As you can see here in the objects window, it's going to give us a countdown. So that might take a second or two because it's got quite a lot of calculations to do there. Okay, there we are, that's done that. So that's machined that outside shape there, which looks pretty good. Okay, so the last thing to do there would be to finish off the flat area. So if we go into advanced machining, and then the tool we're going to use, we'll use the 10mm end mill. And under surface paths, we're sticking to triangle mesh, but the pattern we want is going to be flatlands. The machining surfaces, again, we have to tell it which model that we want to use. There is no offsets on here because this is the finishing paths. And we can set up the step over. So let's have, say, 2.5mm there. So what this will do is it will just find the flat areas, which is just that part there. So that's pretty much machined all of that. If we wanted to simulate it, we go into the simulator. We've already set up various values here, so that gets saved away as a stock file. Again, this is just for the simulation, so we press simulate. and that then passes all the information needed through to the machine tool simulator. Okay, and then we can run that, speed up the display, and so on and so on and so on. Okay, but we could also fast forward around that as well. So I switched off the roughing toolpath earlier so that we didn't see that on the screen, but you need to switch that back on to see it within the simulator. Okay, so that's that. So we can come out of that, back into the 3D cam. So this was the operation which I switched off, and to see it again we just make it active, and then we'll see that in the simulator. Now, as well as controlling all the depth of cuts and so on, the other thing that you can do with all of these operations is when you go into them, then you can use the link tab here to set up any ramping that you want, but more importantly the retract of where it's going to go to in Z. So that's how you do it.